Hi everyone. So today I will be starting the discussion on chapter 4, circular motion. Okay, so when it comes to circular motion, the first subtopic we discuss under the lesson is angular speed. Okay, so they say if a particle is moving around a circle of radius r meter and linear speed v meters per second, and angular speed omega, so we call this omega and it's measured in radians per second. I think you might be already familiar with this, right? So we say the linear speed, we have a relationship between the linear speed and the angular speed, and it is given by the equation v equals r omega. So this is the first main equation you learn in this lesson. V equals to r omega. Okay, so note it down as the first main equation. Okay, so we'll move on to exercise 4a, question number 1. They say express an angular speed of 5 revolutions per minute in radians per second. Okay, so you have to express revolutions per minute in radians per second. So how do we do this? Okay, first thing is you need to realize, okay, what is one revolution? We know now the thing is you have to convert revolutions to radians, okay, and then per minute to per second also. So first thing is you should realize one revolution means when you go one complete round, right? So one revolution is equivalent to how many radians? One revolution is equivalent to 2 pi radians, because 2 pi is when you turn a complete circle, a complete round, isn't it? So they are saying here one revolution, that's 2 pi radians. So we have 5 revolutions per minute. So if you have 5 revolutions, it's going to be what? 5 revolutions means you have 2 pi times 5, isn't it? 2 pi into 5, which means it's 10 pi radian. Okay, so 5 revolutions means 10 pi radian. Okay, and then now the thing is this 5 revolutions per minute. So you have 5 revolutions happening in 1 minute, right? Per minute. So in one, I mean, you have 5 revolutions happening in 1 minute. So this is equivalent to 10 pi radians also. I mean, since the amount is equal, you have here 10 pi radians happening per minute. But I want it per second. So how do I get it per second? How do I make it per second? This is 5 revolutions per second, per minute. So this also is 10 pi rads per minute. So I want to get it per second. So to make it per second, what we do is we have to, now this is per minute. So that's per 60 seconds. So to make it per second, you have to divide by 60. Okay, so 10 pi radians, you should divide by 60. And then that converts this to radians per second. So the angular speed, the omega value will be pi over 6 radians per second. Okay. Okay, so part B, they say an angular speed of 120 revolutions per minute in radians per second. So once again, we have to convert revolutions to radians. So I know one revolution is 2 pi radians. So if it is 120 revolutions, it's 2 pi into 120, right? 2 pi into 120 radians, which is 245 radians. So this is 120 revolutions per minute. 120 revolutions per minute, which means 240 radians per minute. If I want to make it per second, I'll have to divide 245 radians to make it per second. I'll have to divide it by 60. 1 minute is 60 seconds. Then it becomes per second. So what's the answer? So what is the answer? 4 pi, right? 204 divided by 60. Yeah, it's 4 pi radians per second. Okay, so let's move on to part C. An angular speed of 4 radians per second in revolutions per minute. Now they want you to convert radians per second to revolutions per minute. Okay, so how do we do this? So in this case, I want to convert radians to revolutions. So I'll write like this. We know 2 pi radian is equivalent to 1 revolution, right? 2 pi radian is equal to 1 revolution, which means to get 1 radian, if I want to find the value of 1 radian, because I want to get 4 radian. Okay, so I'll make this side 1 radian by dividing, now I know 2 pi rad is 1 revolution. I'll divide both sides by 2 pi. Why am I dividing by 2 pi? So I can get the value of 1 radian. So 1 radian is 1 over 2 pi revolution. Okay, you guys might be doing this in a little bit different ways. That's perfectly fine. Okay, I'm just doing as I go. Okay. So one radian is 1 over 2 pi revolution. Then we have 4 radians. So 4 radians means you multiply this 1 radian by 4. Okay. Okay, so now I'm going to create the 4 radians. Okay, you can see I started with the norm that is 2 pi radian is equal to 1 revolution. And after I got the value of 1 radian, I'm now going to make it 4 radian. I'm going to get the value of 4 radians in revolutions. You can, of course, do this in one step. Okay, so maybe I've written some extra steps here. So you could reuse that. So 4 radians is going to be 1 over 2 pi revolution multiplied by 4, right? Because I want to get the value of 4 radians. So I should multiply this with 4. Right? So 4 radians is equivalent to 4 over 2 pi is 2 over pi, right? So 2 over pi revolutions. So it's 4 radians per second, which means if it is 4 radians per second, it's equivalent to 2 over pi revolutions per second. But they want us to get the answer per minute. So how do I make it per minute? So per second means this is for 1 second. If I want to make it in a minute means 60 seconds, isn't it? A minute means 60 seconds. So how do I make it per minute? Okay, so to make it per minute or for 60 seconds, you simply have to multiply by 60. Okay, so 4 radians per second, you multiply by 60. I mean, these two guys, the per second came from the question. Okay, because it's given in the question that the omega is 4 radians per second. Once I create the 4 radians, I took it as 4 radians per second should be equal to over pi revolution per second because of the question. Okay, and then so to make it per minute, 2 over pi revolution, you have to multiply by 60 because this is per second. Multiply by 60 and you get revolutions per minute. Okay, so it's going to be how much? 2 into 60, that's 120 over pi revolutions per minute. Okay, so you could definitely reduce the number of steps. You can definitely reduce the number of steps and do this in like 2 steps. Okay. Okay, so moving on to part D, an angular speed of 3 radians per second in revolutions per hour. So basically 2 pi radian is 1 revolution, and then we divide both sides by 2 pi to make it 1 radian. Okay, so 1 radian is 1 over 2 pi revolution and we need 3 radians, right? Because if the question is 3 radians per second. So I'll multiply, if I'm taking one, multiplying this side by 3, and the other side also I should multiply by 3. So 3 radians is 3 over 2 pi. And then the question is 3 radians per second, right? So it's 3 radians per second, which means it's 3 over 2 pi revolutions per second. So I want to make it revolution per hour. How do I make it per hour? So 3 over 2 pi revolution per second is in 1 second. So to make it hour per hour, what I should do is I should first multiply by 60, then it becomes revolutions per minute. And then another 60 to make it revolutions per hour. Revolutions per hour. And then that's going to give us how much? 3 into 60 into 60. That's 5,000. Sorry. That's 3 into 60 into 60. That's 10,800, right? 10,800 over 2 pi revolutions per hour. I think you can cut 10,802. When you cut it with 2, you get 5,400 over pi revolutions per hour. Okay, so this is some basic conversions like converting radians per second to revolution per minute to revolution per hour. So these are some basic things that you should know. Okay, so next I'll move on to question number 3. They say a particle moves on a circular path of radius 25 centimeters. at a constant speed of 2 meters per second. The first thing to notice here is the radius is given in centimeters and the speed is given in meters per second, which means it's a linear speed. They are asking you to find the angular speed. So how do I convert the linear speed to angular speed? So this is where the first equation comes. I gave you an equation in the previous page where you have the relationship between linear speed and angular speed. So we can write the linear speed V is equal to R omega. Omega is the angular speed. So V is 2 meters per second. Radius is 25 centimeter. But remember now, if your speed is in meters per second, your radius can't be in centimeters. Your radius also should be in meters. So 25 centimeter to convert to meters, we'll divide by 100. Okay, divide centimeters by 100 to get into meters, into omega. So then I get here 2 into 100 divide by 25. Right, so what do we get here? 25 times 1, 25 times 4. So that's 8. 8 radians per second. So omega is equal to 8 radians per second. Okay, so moving on to part B. They want you to give the answer in revolutions per minute. So how do you convert revolutions per minute? Of course, we'll convert the omega, the radians per second, to revolution per minute. So it's going to be 8. So we know 2 pi radians is, 2 pi radians is equal to 1 revolution. Yes. And then you divide both sides by 2 pi to get the value of 1 radian. So 1 radian is equivalent to 1 over 2 pi. And then we have so then 1 radian. So now I want 8 radian. So I'll multiply by 8. So 8 radians per second, because it's the 8 is the amount we require and it's 8 radians per second. Omega is given as 8 radians per second. So 8 over 2 pi is 4 over pi revolutions per second. And then they wanted revolutions per minute. What do? Simply multiply by 64 over pi into 60 and we get revolution per minute. Right? So 4 into 60, that's 240 over pi revolution per minute. So this is the angular speed of the particle in revolutions per minute.